I am presenting for the high voltage lab of section 1. PDZ 100.0.1 is a single-phase AC voltage test transformer. It can be used for AC voltage generation and as high voltage supply for DC and impulse voltage configuration. The output power can be extended by cascading the transformer. Cm is measuring capacitor that can be used as high voltage unit of AC voltage divider. Rm is measuring resistor. It can be used as high voltage unit for the DC voltage divider. Es is grounding switch. It remote control switch which can be used to ground the high voltage construction kit. Est is discharge and grounding rod for manual discharge of high voltage kit components. El is top electrode for AC 2 and 3 stage. A top electrode on the test transformer is recommended to avoid corona effect. As is insulator support that can be used as insulating component. Kf is sphere gap. Sphere gap for impulse voltage configuration. AFK is derived of sphere gap. Remote control drive for sphere gap KF. Drive shaft ASA short for first stage and ASB long for second stage and third stage is needed. The AFK is clamped onto the spacer bar D. V is connecting rod. Conductive connection element, which is in aluminum rod. K is connecting card. Conductive connection element of 4 components can be connected horizontally and 2 components is in vertically. Fs is floor pedestal. Conductive element for mount up of 4 spacer bars horizontally and supporting 1 component vertically. D is spacer bar. Spacer bar which can be used for mechanical and electrical connection at ground level insert into a floor pedestal, which is Fs. NTZ is secondary part of CB impulse. Secondary unit for the impulse divider which can incorporate the LV capacitor. A 500 ohm matching resistor can be connected additionally. Connected between the HF socket of the load capacitor CB and the DMI 551 or picoscope by means of a coaxial cable BNC. ZSC is a secondary part of CMSC. Secondary unit for the AC divider which incorporate the LV capacitor. Connect between the HF socket of the measuring capacitor CM and the DMI 551 or picoscope by means of the coaxial cable BNC. The mechanical construction is equivalent to NTZ. Thank you.
Okay, today I will be presenting on assembled AC generation and measurement system. So we will start with the frequency converter. The frequency converter is connected to the transformer, which is the PZT transformer. It is a must to do a grounding for safety purpose. So to obtain the high voltage level, the 2 PX and the 1 PU should be connected together at the primary side so that the whole potential can be obtained from the 2 PU and 1 PX. The potential that from the lowest to the highest that we can obtain is from 0 kV to 100 kV. So the voltage flow from 2 PU to 2 PX is only 220 voltage, which is not enough to achieve the required voltage. So that is why the connection of 2 PX and 1 PU is very necessary. So next we will be talking about the 2 capacitors which will be connected to the transformer. So the features of the capacitor, the first capacitor is the measuring capacitor. Okay, the measuring capacitor has a top electrode on top of it. It is to avoid the corona effects. And the top electrode is mainly for AC generation, and this measuring capacitor is used to sustain high energy, and the value of the capacitor is 100 picofarad, and it is used as a voltage AC voltage divider, and the maximum AC voltage is 100 kV, and it is a oil filled type of capacitance. So the second capacitor is a secondary device, which is also known as secondary capacitive device, and there is no any polarity required when connecting with coaxial cable. So it is to connect between the HF socket of the measuring capacitor and picoscope by means of a coaxial cable. So every serial number, the way of setting and the value stated on the secondary part is different from each other, and the measured capacitor value is 1.09036 microfarad, and the rated voltage is 7 voltage RMS, which means that the coaxial cable can only sustain 7 VRMS, and the rated capacitance is 2 microfarad, and the serial number that the serial number of the capacitor that we have used is 223410760-04, and the number of capacitance inside this capacitance is 20, and the divider ratio is 20001, and also the rated frequency is from the range of 10 Hz to 400 Hz. The connection from the transformer to the measuring capacitor is done by using connectors. So we should place a connecting cup on top of the top electrode, then make a bridge like structure from measuring capacitor to the transformer using a connector. A male to male cable is used to connect the measuring capacitor and secondary capacitive device. The copper grounding should be connected from the transformer to the measuring capacitor and also to the secondary capacitive device. It's very important to connect the grounding for safety purpose, as we are handling with high voltage devices. So the earthing from the secondary capacitive is connected to the measuring capacitor. So this method is very important to sustain the safety.
Okay, I will explain my part, which is section 3. Okay, this section, this is schematic diagram of male BNC coaxial cable, and I will explain about BNC connector. Okay, in this lab, we use BNC, which is Burial Net Concealment Connector, that connect and disconnect to radio frequency connector used for coaxial cable. Okay, this type of cable is RF coaxial connector, which is diameter 0.570 for male and 0.436 for female. The interface specification for the BNC are referred in MIL STD348. BNC connectors are made to match the characteristic impedance at the 50 ohm or 75 ohm, which other impedance such as 93 ohm for alternate electrode, the less common. BNC usually apply for frequency below 4 GHz and voltage below 500 volts. In this lab, we use N connector male adapter. Okay, next this is schematic diagram for final stage. They have 6 connector, which is 2 VM1 and VM2 is for AC connection, while VM3 until VM6 is a DC connection. And we in this lab we use a AC high voltage that use 7 RMS. Okay, secondary unit for the AC divider, which incorporate the LV capacitor, a 50 ohm matching resistor can be connected additional. Connected between the HF socket of the measuring capacitor CM and the MDI 551 by means of a coaxial cable BNC. The mechanical construction is equivalent to SEK IMP. The output voltage circuit board for DMI is 140 volts. The connection between the two capacitor divider using coaxial cable and the other end of secondary capacitor is connected to the termination point of FC. Okay, next, BNC connector gender can be confusing, but can be classified them by their gender if it is plug or jack. So Jack commonly refer to a connector which females electrical contact or socket, and is more often what is affixed in the device or panel, while plug commonly refer to movable connector, often with a male electrical contact or pin, and it's more often the cable, more often a movable connector of a pair. There are two types of gender of BNC, which is a male BNC and female BNC. Male BNC connector have a male center pin, while female BNC connector have female center socket. So, the gender of BNC derived from the gender of the contact, not the gender bayonet connection. BNC connection has a bayonet connection that is opposite gender of the center contact. As mentioned, really, most connectors are gendered, but some connectors like SMB and RPSMA are what we call is reverse polarity connector. Okay, now I will explain this is about grounding for secondary. Figure show grounding for secondary male to male connection is used to connect secondary to capacitor and hold the system. Okay, this is a banana to female. Okay, function this to connected to secondary. Before connecting the banana adapter and female, make sure the connection point first, whether it's ground or inner, because secondary have 2 points. So, how to identify the grounded? See the level GND at the adapter. For this connecting does not have a polarity because it's same like a capacitor. Okay, this is figure for grounding system for AC high voltage. The figure show grounding system for AC high voltage for this laboratory. Copper braided is connected to the terminal grounding. Before start the experiment, we must check all the apparatus first, which is that all apparatus must connected not connected lah, connected to the earthing. And then other than that, we must make sure 2 px and 1 pu contact, so that we can get potential from 1 px to 2 pu from 0 to 100 kilovolts. Now I will explain for section 4, which is neatness and clean. So we must keep the lab on clean, dry and safe. So firstly, we must keeping workshop or storage space clean and dry can help prevent many accidents. Spark can ignite scrap, cinders and solvents. Water can conduct electricity, so do not stand in water, on the floor or in the rain when working with electrical tools. Keep hands and tools dry. So the second step is make sure workshop and storage area have a proper electrical wiring and outlet needed to run power tools. Install adequate wiring to handle the electrical load required. The step 3 is all outlets should have 3 pronged lock or be double insulated. Any outlet that may come in contact with water should have a ground fault circuit interrupters. For step number 4 is never use indoor tool outside. Use only approved outdoor extension cord. Use on one long extension cord instead of several short ones. Do not damage or cut extension cord. And when working on ladder or scaffolding, rest power tool on a flat surface or in a bin secured to be ladder itself. A falling tool can seriously injure a co-worker or bystander. Never carry heavy power tool up and down the ladder. Step number 6, stop working and turn off power tools you are working, which is distracted by something or someone. Never look away from work when operating a power tool. That's all.